Okay, in this video, I would like to look at an example of an urn problem. The problem states an urn contains 6 red marbles, 5 white marbles, and 4 blue marbles. A child is going to randomly select 3 marbles without replacement from the urn. I want to answer 3 questions. What is the probability that all 3 marbles are white? The second question I want to answer is, what is the probability that none of the marbles are blue? And the last one is, what is the probability that the marbles are all the same color? Let's examine closely the question of what is the probability that all 3 marbles are white. Before the first draw, let's consider the urn, and here I'm drawing the urn as a box. The urn contains 6 red marbles, 5 white marbles, and 4 blue marbles. That's 15 total. So if we're going to reach in and draw, instead of drawing 3 marbles all at once, let's draw them one at a time. We're just not going to put them back in the urn. So when the first marble is drawn, the probability that the first marble is a white marble is going to be 5 out of 15. 5 white marbles out of 15 marbles total. Now, suppose that has occurred. Suppose the first marble is white. Then, before we draw the second marble, we need to update our urn. Our urn now has 4 white marbles, 6 red marbles, and 4 blue marbles. The probability that the second marble is white, given that the first marble was white, is 4 out of 14. 4 white marbles out of 14 marbles total. Now, suppose that both have occurred. Suppose the first marble was white and the second marble is white. Before the third draw, there are now only 3 white marbles left in the urn. And the probability that the third marble is white, given that the first and second were white, is 3 white marbles out of 13 marbles total in the urn. Notice that with each draw, there's 1 fewer marble in the urn, and if we are drawing white marbles, there's 1 fewer white marble. So what is the probability that all the marbles are white? So I want the probability that the first marble is white, and the second marble is white, and the third marble is white. So, the probability that all marbles are white is 5 out of 15 times 4 out of 14 times 3 out of 13. I'm just multiplying the conditional probabilities that we got previously. This is the probability that the first marble is white times the probability that the second marble is white, given that we know that the first marble is white, times the probability that the third marble is white, given that we know that the first 2 marbles were white. The product of those fractions is 0.02198. I've rounded off to 5 decimal places. So what is the probability that none of the marbles... One thing to notice is that I've set up this calculation where I've given myself space for each marble. We're going to draw 3 marbles, and I'm making a note to myself. I want the first marble to be white, I want the second marble to be white, and I want the third marble to be white. The probability that all the marbles are white occurs by systematically multiplying. First, I'm going to look at the probability that the first marble is white, and then I go down the progression. Okay, I think to myself, if I can think in my head what is going on with the urn, now if the first marble was white, there are 4 white marbles left and 14 marbles total left. And so I get that 4 out of 14. And then the 3 out of 13, the second marble is drawn out. We have 3 white marbles left and 13 marbles left. So let's apply this to more quickly compute the probability that none of the marbles are blue. Looking back at our original box, our original urn, 6 marbles are red, 5 marbles are white, 4 marbles are blue. So what is the probability that none of them are blue? Well, in order for that to occur, I want the first marble to be not blue, and the second marble to be not blue, and the third marble to not be blue. So, looking at the original box, at the original urn, there are 11 marbles that are not blue out of the 15 total. If the first marble is not blue, that leaves us 10 non-blue marbles left out of 14 marbles total. If the first 2 marbles were not blue, then we'll have 9 non-blue marbles left and 13 marbles total. The product of those, using the multiplication rule, we can find the product. 11 out of 15 times 10 out of 14 times 9 out of 13. And we get about 36% probability. The last one is going to take a little bit of an addition. Not only do we want to use the multiplication rule, but we actually want to use the addition rule as well. So, in order to get all the marbles the same color, one of 3 things has to occur. Either all of our marbles are red, or all of our marbles are white, or all of our marbles are blue. One thing to note, for example, if all of our marbles are red, then we can't have all of our marbles be white. We can't have white, white, white. So that means that these events are mutually exclusive, which means that we can find the probability of all red, or all white, or all blue by adding the probability of all red to the probability of all white to the probability of all blue. I'll leave it to you as an exercise, using part A as a model, to confirm that we get that the probability of all red is as written here in red, the probability of all white is as written in black here, and the probability of all blue is as written in blue, the third term. And this is what I got for the probability of all the same color.